Hi students, once again I welcome you to my channel Abrar sir classes. ಇವತ್ತು ನಾವು ಕರೆಂಟ್ ಎಲೆಕ್ಟ್ರಿಸಿಟಿ ಚಾಪ್ಟರಿನ ಮೀಟರ್ ಬ್ರಿಡ್ಜ್ ಟಾಪಿಕ್ ಮೇಲೆ ಪ್ರಾಬ್ಲಮ್ಸ್ ನೋಡೋಣಪ್ಪ. ದಿಸ್ ಇಸ್ ಪಾರ್ಟ್ 1. You have to solve these kind of problems just in 45 seconds. We will see the very first problem. What it is saying, resistance in the two gaps of a meter bridge are 10 ohm and 30 ohms. ಇದು 10 ohm ಅಂತೆ, ಓಕೆ, ಇದು 30 ohm ಅಂತೆ, okay, respectively. If the resistance are interchanged, the balance point shifts by, okay, this is 30 ohm, now this is 10 ohm. ಇದು 10, ಇದು L ಅಂತ ಇಟ್ಕೊಳ್ಳೋಣಪ್ಪ. ಓಕೆ, ಲೆಟ್ ಮಿ ಕಾಲ್ ದಿಸ್ ಇಸ್ L. ಇದು L ಸೆಂಟಿಮೀಟರ್ ಅಂದರೆ ಇದು 100 ಮೈನಸ್ L ಸೆಂಟಿಮೀಟರ್ ಆಗುತ್ತೆ, ರೈಟ್? This whole thing is 1 meter. That's why it is called meter bridge. That's why it is called meter bridge. ಈ ವೈರ್ ಇದೆಯಲ್ಲ, this wire is of 1 meter, 100 centimeter. Okay, right. Now, this is the concept of what? Wheatstone bridge. 10 by 30 is equal to L divided by 100 minus of L. Okay, for the very first circuit diagram. Okay. ಎಷ್ಟಾಗುತ್ತಪ್ಪ ಇದು? 0 0 gets cancel. 100 minus of L, if I cross multiply, is equal to 3L, right? So 100 is equal to 4L. L is equal to how much? You are going to get L is equal to 25 centimeter. Okay, now what he is saying, these two resistances are interchanged. So at a time, what happens? This will become what? This will become 100 minus L ಆಗುತ್ತೆ. ಇದು ಎಷ್ಟಾಗುತ್ತೆ ಆವಾಗ? ಇದು L ಆಗುತ್ತೆ. ಓಕೆ, L ಸೆಂಟಿಮೀಟರ್. ದಿಸ್ ಇಸ್ 100 minus L ಸೆಂಟಿಮೀಟರ್ ಆಗುತ್ತೆ, ಇದು L ಸೆಂಟಿಮೀಟರ್ ಆಗುತ್ತೆ. How much we got L? This is 25 centimeter, right? Okay, we got 25 centimeter. This will be how much? 75 centimeter. Now this will be how much? 100 minus L andre this is 75 centimeter now, and this is 25 centimeter. But what is the question? The question is, if the resistances are interchanged, the balance point shifts by anta ide. Okay, that is very good. Shifting of balance. Okay, shifting of balance point. Shifting of balance point, okay, will be equal to, okay, how much it will shift by? Earlier how much it was? 25 centimeter. Now how much it is? 75 centimeter. Okay, therefore 75 minus 25 and rest agutappa is equal to 50 centimeter is the right answer. Okay, it shifts by how much? 50 centimeter. Hope you understood. Same Wheatstone bridge concept now is model. Okay, this by this 10 by 30 is equal to L divided by 100 minus of L. Okay, hope you understood. We'll do the next problem. Yenappa, in the shown arrangement, okay, in the shown arrangement of the experiment of the meter bridge, if AC corresponding, okay, if A, okay, C corresponding to null deflection of galvanometer is X, this is C. Okay, this is C. This is the balance point. Okay, in the shown arrangement of the experiment of the meter bridge, if AC corresponding to null deflection of galvanometer X, what would be its value if radius of the wire AB, okay, this wire AB is doubled, radius is doubled. One thing you remember about null deflection, okay, null deflection does not change by changing, number one, material of the wire, okay. Null deflection does not change by changing material of the wire. Number two, area of cross section of the wire, area of cross section okay, of the wire, and number 3 is what? EMF of standard cell. EMF of standard cell. Okay. So this belongs to what? Area depends on what? The radius. Okay. So there is no change in the null deflection. It will be at x itself. This is the right answer. Okay. This is the right answer. X itself. Okay. If you double the radius, there is no change in the null point. It will be x only. Hope you understood. Next problem. In the meter bridge shown, the resistance X has a negative, negative temperature coefficient. This resistance has what? Alpha is equal to what? Negative. Negative. Alpha is what? Negative. Okay. What happens if alpha is equal to negative? Then, if temperature increases, then what happens to the resistance here? In the meter bridge shown, the resistance X has a negative temperature coefficient of resistance, neglecting the variation in other resistors. Okay, when current is passed for some time, in the circuit, balanced point should shift towards okay. What happens when the temperature increases? Okay, when the temperature increases, the resistance, what happens? Decreases. The resistance decreases. Okay, for some time. When current is passed for some time, there is a what? Temperature increases. When there is a temperature increase in the temperature, what happens? The resistance decreases. When there is a decrease in the resistance, opposite length ಎಲ್ಲ ಆಗುತ್ತೆ. Okay, what happens to CB? ಈ ಜಾಕಿ ಇದೆಯಲ್ಲ, okay, slightly it will shift to what? It will try to shift this side. Okay, it will try to shift towards what? B, because here what is happening to X? Okay, X is getting decreased. Therefore what happens? This length also decreases. ಈ ಲೆಂತ್ ಇದೆಯಲ್ಲ, ಈ ಜಾಕಿ ಇದೆಯಲ್ಲ, ಇಲ್ಲಿ ಬಂದ್ಬಿಡುತ್ತೆ. The point C will come here. It tries to shift towards what? Shift towards B. This point C shift towards what? B. Okay, because alpha is negative. If alpha was positive, okay, if temperature increases, what happens to resistance? Increase ಆಗ್ತಾ ಇತ್ತು ಇದು, it will try to shift towards here. Okay, but here alpha is negative. Therefore temperature, okay, if temperature increases, resistance decreases. Therefore this, okay, null point tries to shift towards B. Okay, towards B. Hope you understood. Okay, I think we have finished 3 problems today. Hope you understood. If you like this okay, video, kindly subscribe for my channel, kindly share it with your friends, and like it, and then ask doubts in the comment box. Okay, I'll be coming with interesting problems on your all chapters and all topics of your Kcet physics. Hope you have understood all the 3 problems. This is the very first problem. Okay, this is very easy, based on Wheatstone bridge. And the second problem is just, okay, remember, null deflection does not change by changing what? By changing material of the wire, area of cross section of the wire, and EMF of standard cell. And in the last, okay, alpha is negative, temperature increase ಮಾಡಿದ್ರೆ X decrease ಆಗುತ್ತೆ. Okay, therefore it try to shift towards B. Hope you understood. I'll stop it here. We'll meet in the next video. Thank you, one and all the best.